part 2 of the introduction to continuity. Pick up on that cliffhanger, look at the visual representation of this intermediate value theorem. So basically, let's get a little function drawn in here. And it says if it's continuous on an interval a to b, so let's just go ahead and say this is a, this is b, and we can see that the function in between a and b is continuous. Don't have to lift the pencil at all to draw that graph in between those two endpoints. So you have this a to b. Well, there's a value n between the f of a and f of b. So some value n, let's just put that there between those two function values. Well, if that's all true, there must be a number c in between a and b such that the f of c equals n. And looking at this visually, it's pretty clear. There's n right here that would kind of take you over to here and bring you down to here. Well, there's the c value. That c will give you an f of c that equals the n. And because this function was continuous, this is what is driving this idea. There's all of the values in between fa, fb being represented. So any y value between that fa and f of b has to have an x value associated with it. It's basically what the intermediate value theorem is saying. So why is this theorem useful? What can we use it for? Well, it allows you to verify that a function has a zero or a root in a certain interval. So for example, let's verify that the following function has a zero, place where it crosses the x-axis in the interval -2 to 2. And the function I'm going to look at here, f of x equals x cubed plus 1. So in order to show that it has a zero in between that interval, you really just evaluate at the endpoints. So you find f of -2. This would be -2 cubed plus 1, or -8 plus 1, which is -7. And then you have this f of 2, the other endpoint, 2 cubed plus 1, or 8 plus 1, which is 9. So what we can take from this is that -7 to 9, those are y values. Somewhere in between there is a zero. In between the negative and the positive is a zero. So we can safely say that 0 is in between -7 and 9. And because this x cubed plus 1 is continuous, there must be a c, some x value, such that the f of c will equal 0. So what that really means then overall, i.e., a 0 exists between -2 and 2 on this graph. And if you were to look at this graphically, you would see something like this. And if you were to look at the numbers here between -2 and 2, that's the place where it's going to be crossing. So at any rate, that's how you use the intermediate value theorem to show that zeros exist. And that also completes this video and completes the introduction to continuity. Thank you for watching.